So this homework problem is a Bayes problem, and it corresponds pretty closely to an example quiz question. Now I've kind of marked some of the correspondence between the quiz questions and the homework problems in the quizzes, so look for that. And it says, suppose 5% of housing projects have issues with asbestos. The sensitivity of a test for asbestos is 93% and the specificity is 88%. What's the probability that a housing project has no asbestos given a negative test expressed as a percentage, blah, yada, yada, yada. So I've gone ahead and written out the information here. A is the event that the house has asbestos. D plus is the positive test. D minus is the negative test. And what I've been given is this marginal probability of a house having asbestos is 5%. The sensitivity of the test, which is the probability of a positive test given that the house has asbestos, is 93%. The specificity is the probability that the test is negative given that the house does not have asbestos, and that's 88%. And we want the probability that our house does not have asbestos given that we had a negative test. That's what we'd be interested in. Okay, so this is equal to the probability of A complement intersect D minus times, or divided by, the probability of D minus, which is equal to the probability of D minus given A complement times the probability of A complement. And probability of D minus is equal to probability of D minus intersect A complement plus the probability of D minus intersect A. And now we can write, let me start over on this line. Let me rewrite the numerator. That's the probability of D minus given A complement, which is the specificity, times the probability of A complement, divided by the probability of D minus given A complement, which is the specificity again, times the probability of A complement, plus, now let me work with that guy, that's going to be the probability of D minus given A times the probability of A. So let's start plugging in our numbers. The specificity is 0.88. The probability of A is 0.05, so 1 minus that would give us the probability of A complement, so that's 0.95. Okay, and then this is just the numerator repeated again, so that's 0.88 times 0.95 plus, so this is the probability of D of a negative test given that the house has asbestos, and that's 1 minus the sensitivity. So remember, let me just point this little fact out. Let me use different letters too, just so we don't get confused. So let me say B given C. I want the probability of B given C plus the probability of B complement given C is equal to 1. And the way to think about this is when I condition on something like given C, then the probability just works like a normal probability as long as I have everything just conditioned on C. So probability of B plus probability of B complement equals 1, just because if I didn't condition on C, that would be true. And if I condition on C and keep C conditioned on in every probability, then all the same rules of probability apply. And that's an easy trick that you can use to calculate conditional probabilities so you don't get tripped up. Okay, so in other words, what we want probability D minus given A, but we have the complement probability D plus given A, but the condition on A is the same, so we can just 1 minus it, so that's 1 minus 0.93, so that's 0.07, times the probability of A, which is 0.05. And this works out to be about 100%. So I'm going to click on 100% and click submit, and then let me show you the answer where I actually plug it into R.